Welcome learners for the lecture 8 of a differential geometry. Today we discuss about the topic that will be considering as a tangent curve and a tangent plane of the surface. Okay, let us go started as a definition will be considered in a tangent form, that is the second definition. First definition show in the previous lecture. The normal to the surface at a point P is a line through the point P and perpendicular to this tangent to the plane at a P. Since R1 and R2 lies in the tangent plane at a P and passes through the point P, the normal to the perpendicular points on the both of the equation R1 and R2 are is considering, and its parallel to the R1 into R2 as adjoint figure to normal to the following content of the conversation. Okay, this will be the considering to the tangent of the form. This will be generated to the equation that will be when this is the R1 and this consider as a R2 and this is a point P. Both of this considering to R1 and R2 is a cross to the point P, and this tangent of the curve is going to the another point. This first R1 is generated U equals to constant and R2 is generated as a V equals to constant. If getted as a Moore line for this point, for the most of this equation will be considering for the point is the perpendicular as well as the crossing to the point, and this P is generated as a normal to this condition. Okay, this will be the fixed point to showing as a conversation of this form. Next, let us go considering to the form of the equation. If n denotes the unit normal at a P, then R1, R2 and n. What is n? N is a normal of the point when R1 line of the curve and R2 line of the curve is adjoint, or they will be adjoint to the point P of this equation of the order should from a right-handed system. Using this conversation, we given that R1 plus R2 upon mod of a R1 into R2 equals to generated to the form R1 plus R2 upon H will be given to the form, where H is the mod of a R1 into R2 in this form. Okay, since you know that R1 into R2 is not equals to 0, hence H R1 into R2 in a mod form is not equals to 0. We show that it is always a positive number and NH equals to R1 into R2 will be generated. Okay, N is a normal and H will be given to the form of this right-handed rule. Next is a theorem second will be generated. The equation of the normal n at a point P on the surface R equals to RUV is the capital R equals to small r plus A. They generated R1 into R2 in this proof of this equation. Let R be the position vector of any points or the normal to the surface at a P whose position vector is given to the form, that is R equals to RUV. For the domain will be considering, you know that R1 into R2 is not equals to 0 given to the direction of a normal, and capital R minus small r lies along to the normal. That means R1 into R2 and capital R minus small r are parallel. So to considering to the form, that is capital R minus small r equals to A into R1 into R2, where A is a parameter of this form. Okay, hence R equals to generated R plus small a R into R2 gives the equation of the normal at a point. Theorem 3, considering to the form, a proper parametric transformation either leaves every normal to unchanged or reserve the direction of a norm. It is a important theorem to given to the form or the questioning asking to that theorem. Okay, what is the proof? What we say, proper parametric transformation either leaves every normal unchanged or reserve the direction of the normal. R equals to small r, W and V be the given surface, and let the parametric transformation be U dash equals to phi of a UV and V dash equals to psi of the WV. Both of these condition will be changes U, V, W in this equation. Okay, since the parametric transformation is a proper when J is a Jacobian form, will be considering to the equation J equals to generated to the form, that is a del of a U dash V dash upon del of a UV is not equals to 0. For given to the condition, that is R1 into R2 also is not equals to 0, for given to the case of this equation. Okay, in this case we generated del R upon del U into del R upon del V equals to del of U dash V dash upon del of UV. They considering both of these bracket, del R upon del U dash into del R upon del V dash in this condition. This will be the generated H and H dash handed rule for given to the equation, that is the Hn equals to del of a u dash v dash upon del uv H dash n dash will be generated. Since H and H dash are always positive, n and n dash are considering same sign if Jacobian j is greater than 0 and are the opposite sign to given to this condition. J is continuous function on the both of these parameter w and v whole of the domain, and j does not vanish in a d. J returns to the sign in the d of this form. Hence, this proves that n and n dash have the same sign for given to the condition.